seats and we'll go ahead and get started. Grab your pizza, grab your beer, grab your partner, spinner. I don't remember how, what is it called? Square dancing? Yeah. You know what I'm talking about? Square dancing? Nobody?
Oh, square dancing.
Yeah, square dancing. True enough. All right. So, welcome, everybody. Took a little bit of a break in May. I guess you were, in particular, took a break from Orlando. How long was it, by the way?
7 months.
7 months? Yeah. Well, welcome back. Glad to have you. So who here, I like to check in, who here is here at this particular meetup for the first time this evening? Welcome, welcome. What you told me your name already. What was it? Anthony and
G.
G. Just G? Just the letter G? Gene, got it. Cool. Welcome, Gene and Anthony. Anybody else new? First time? Oh yeah, we met earlier, right? Welcome. Cool. So, this is an interesting night for me. I have never spoken at my own meetup before. So, I get to introduce myself. My name is Alex. I'll be talking about a concept that I totally made up. I think I made up anyways, called Humane architecture. It's just kind of this idea that's been kicking around in my head for a while, and have a captive audience, so we'll see how it goes. And then Santosh is going to be talking about Azure API management. He's actually, last year you gave a talk about databases, and it was honestly, I mean this completely authentically one of my favorite talks we've had here, so super excited to have Santosh back. Cool, let's talk about upcoming events. So June 25th, we have Project Codex. Is anyone, well, Joe didn't make it, so if you don't know what Project Codex is, it's basically, the idea is like junior and senior developers work together on projects to, to provide mentorship. I think personally, mentoring people helps you mentor yourself, so I think it's a win-win. But that's kind of the idea there. Orlando Python is also.
Can I talk about Project Codex?
Yeah, go for it.
So the Project Codex meetup, one plug is running that with Project Codex.
Oh, I didn't realize it was a collaboration.
Yeah, so
that's why it's C# for Java. Oh, now I get it. Okay.
It's C# for JavaScript developers. So what happened?
What happened was, I think there was a Orlando devs meetup, and a lot of people at that meetup realized that C# developers make a lot of money. So JavaScript developers want to learn C#. So if you're interested in the basics of C#, and if you're interested in making a lot of money, you should probably show up for that meetup.
The Python group isn't also involved there because they're also the 25th, so you have choices. Code for Orlando that can't be right. That's got to be July 2nd, unless I did that in the wrong order. Probably July 2nd, I'm just guessing. July 8th is Orlando Devs, July 9th is Orlando Tech, July 10th is SQL Orlando right here, and July 10th is also Orlando IoT. Any other, I try to do the best that I can with this, but is there any other meetups worth mentioning while we're on the subject? All right, cool. So thank you to our one and only sponsor, which is also my employer. This is getting very weird now. I promise it's not normally this. Yeah, exactly. We are, as always, looking for speakers. If you're inspired by what you see here tonight, don't have to be an expert. Inspiration is the main thing. So just come talk to me, reach out to me on Slack, talk to one of my other organizers, and we'll see what we can do. There is, of course, free beer and pizza back there if you haven't helped yourself yet. So please do that. I don't need to take like 3 boxes of pizza home or beer. And then, of course, any comments, feedback, or suggestions, shout at me, find me in Slack, email, whatever you want to do. Any other questions before we get started tonight? All right, so as I said, this is going to be different because I get to introduce myself. So Alex Denton is talking about humane architecture, which is a concept that he invented, and so give him a round of applause. Woo! kind of started this talk with like more of a desire to give a talk than a specific idea, and it kind of evolved over time. I thought to myself, we've been meeting, this particular group has been meeting about 1.5 years, close to 2 years, I think. We've covered a lot of topics. And yeah, that's probably not even a full list, but this is just, a list of some of the really awesome, cool things that we've talked about in 1.5 years-ish. And I was like, man, it'd be really cool if I could somehow give this like mega talk to like cover all of it. And I pretty quickly realized that just wasn't realistic. So I was like, I still kind of want to speak to, there's just so much information. Like this is not just a problem for this meetup, this is really a problem for our time in human existence, right? We have way too much information, too much advice. Oftentimes it's conflicting. So like, really more than anything, what we need is not like, these talks are great, by the way, Santosh, thank you. I'm super happy that you talked to us. These are great, but like, I wanted to try to give you a framework for deciding how to apply all of these good ideas. We'll see if it's successful. The thing about advice is it's always contextual, right? Advice that I give you in one situation that's good advice is going to be bad advice in another situation, right? So oftentimes they'll read a blog or they'll go to a talk and they'll say you should do X, Y, or Z, and they're right for their situation, right? But there's very few things in technology, there's very few things in life that apply universally, right? So the trick is, how do I take this contextual advice and synthesize it in a way that I can apply to my specific context? So that's what I'm going to try to provide tonight. You guys let me know at the end how I did. And also, I should probably say, like, I'm really not going to say, this is like the worst sales pitch for a talk ever. I'm probably not going to say anything like completely novel, because there are frameworks out there already. There's Agile and Lean and Scrum and Kanban and DevOps. These are, supposed to provide you with a way of, if not making decisions, at least like structuring your work and all of this stuff. I think where they all miss the mark, however, is basically just branding, right? Because agility in and of itself is really not the goal, right? Being lean is not really the goal. Your velocity on a Scrum team is really not the goal at the end of the day. In the world of DevOps, like, automation is great, but it's really, at the end of the day, not what really matters. The goal is to add value to, your product, for your customers, hopefully to the world, right? So the question is, how do we do that? And that's what all of these, software development methodologies, all of these blog posts, all of these things are trying to speak to is like, fundamentally, how can we add more value? And really, what I think it comes down to is they're trying to empower the humans that are writing the software and using the software, right? So the kind of pseudo-unique thing about software, I think you could make this case for all value that's created in the world, is that it all comes from humans, right? Like, we do have the limited ability to like write programs with AI, but we're a long, long way from that being a practical thing, right? So for all intents and purposes, if you need to add value, you need the humans to do it. And by definition, that makes them the biggest bottleneck to adding value. And I think, when I think about like, who's worked in something that's self-described as Agile or Scrum? About half the room. What about Lean? Yeah? Okay. I mean, you've probably, like, if you've been in an Agile environment, you've probably at least once encountered this state where like, people start obsessing about like velocity or something, right? And it's like, I mean, it's cool, it's helpful, it can be very useful, but like hyper-fixating on that metric or or this idea that you need to be agile, agility is an important dimension to like productivity and doing things right and enjoying your work, but it's not really the thing that you're after. Same with lean. Like I will say in particular with lean, people can get hyper focused on like, we just need to find the MVP and like we'll iterate later and it'll be fine, guys, right? But that hyper focus on being lean, it all feels to me like a branding problem. So, what I'm going to try to do is take this idea that humans, like all of these ideas are about making life better for the humans that are writing the software, and show you how using that and observations about human nature, you can drive decisions on these kinds of things where there might be conflicting advice. So, again, what is humane architecture? Focuses on empowering humans that work with it and uses observations about human nature to drive decision making. So, let's make some observations about human nature. Tell me if you think they're true or false. Humans are bad at predicting the future. Who thinks humans are good at predicting the future? No? How about humans are bad at predicting the future? Some people don't like raising their hands, that's fine. Humans are good at adapting to new problems. Do you agree with that?
Yep.
It's kind of our unique party trick at the end of the day. There are animals that they can make nests and use tools a little bit, but really in the universe, as far as we can tell, we're the only thing that can really truly adapt to new problems, at least say in our lifetime. Evolution does a pretty good job of it. Humans, however, are slow at learning new things, right? So if you compare downloading a program and running it on your machine to how long does it take you to master C#, right? Probably thousands of hours to really master anything in life. So in comparison to what machines can do in terms of hey, I'm going to download this binary and execute it, if you consider that learning, which is a very liberal definition of learning, we're pretty slow at it at the end of the day. So humans are social, and they find strength in numbers. Now I know that you're largely developers, so you may not agree with that statement, but I will have you note that you are sitting here right now, so I think there's a pretty good chance that you're social creatures. And then humans are bad at managing complexity, right? I think the average person can hold 8 or 9 numbers in their head, right? That's why telephones are 7 digits. No, that's not true. 10 digits? Whatever it is. We're not very good at it compared to a computer that can, store, basically infinite data as long as we build the hardware, hard disk for it. Humans need both autonomy and structure. Who's been on a team that had too much freedom? Who's been on a team that had too much structure, too much bureaucracy? We've all experienced the ends of the spectrum, right? So it sucks. Both of them suck pretty much equally. Although we like to pretend that we like autonomy, we don't. We actually don't like autonomy, full autonomy. It's hard. And then lastly, humans are bad at being consistent. We were talking about this somewhere earlier. If you ask someone to make a widget over and over again, they're the error rate's gonna be pretty high. They might get better over time. Some people are better than others, but if I took you guys and told you to build a birdhouse, the tolerance is gonna be pretty wide. We're gonna get some wonky looking birdhouses, I'm pretty sure. All right, so those are obviously not all of the observations about human nature that you could make, but it should help us in this decision-making process when we're dealing with this excess of information and how we make these decisions. So, languages and frameworks. So I was talking to Ryan, right? And he was talking about just getting into development, right? And I remember, at least way back when, how daunting that was. You first get into programming, it's no, it wasn't you, it was you. Yeah. Sorry.
I know I see it on the floor.
Yeah. Anyways, it's daunting, right? There's so much information out there and so many languages, and like the first thing I remember asking myself is, well, I got to pick the right language. I have to find the best language, right? Obviously, and unfortunately, that's pretty much a useless endeavor, as we tend to learn with time. And this probably isn't groundbreaking information for most of you. I told you I wasn't going to say anything novel, but this is what you might see. You might see things like .NET is better for enterprise development. Make money, right? JavaScript runs anywhere and everywhere. Okay? Go does concurrency really well. Rust has really good memory management abstraction. These are all things that are not only true, we've presented about them here for the most part at this particular meetup. And I think like they're very valid. However, the first thing I would tell you is just if you have a team, just use what they already know. Right? I know that's really boring advice. We like to I love learning about new programming languages, but honestly, just do it in your own time. It's not worth it, right? It takes a long time, again, to get that mastery over a new language. So the first thing I would say is, humans are slow at learning new things, so just accept that, move on if there's an established pattern there. Usually, languages and frameworks are not going to make or break your company at the end of the day. Whether it's Ruby, or Python, JavaScript, or maybe you chose, what did you choose that broke your company?
I didn't choose, but it was loop back.
Okay, except when they do is my next bullet. There are, we'll talk more about this on the next slide, but there are definitely extremes here. You don't want to go off as far on the deep end as you can in terms of your language choice, but by and large, if you choose some of the more popular ones, you're going to survive, I promise you. Because again, humans are the problem here, not the technology most of the time. I'm not saying humans are a problem. You guys are great. But you're slow, and you need to be better, and I'm going to help you do that. All right. So the other thing I would say is, again, use what other humans are using. That's basically the advice there. Like, humans are social. They find strength in numbers. Like, the number of libraries in your chosen language or whatever, the quality of the documentation, these things are generally going to matter a hell of a lot more than whatever nifty memory management feature you have, right? Again, there are domains, like if you're doing machine learning, you're probably going to go with Python, right? In the web world, which is, I'm assuming what most of us are in, Ruby, Python, JavaScript, doesn't really matter. And of course, ability to hire matters. Who's ever been in a position where they could not hire because they had too obscure of a technology or even an outdated technology? Anyone? What language?
I don't even know what it was. It was something,
Didn't even have a name.
It was proprietary, made up stuff.
Yeah, right on. All right, and then the last, I think generally good advice when it comes to languages and frameworks is, humans are good at adapting to new problems, right? So technology will change with time. The language that you're using might get obsolete. The framework that you're using, probably will get obsolete. And that's okay. Like, humans are good at adapting, so they'll figure it out. But what you can do to protect yourself is make sure that you have as minimal dependencies on that framework as possible, right? If you're deeply invested into the framework that you're using, whatever it is, and that framework dies or gets superseded by something else, like, you're in for a world of hurt, right? We went through this with Angular, right? On Power DMS, we thought Angular was going to solve all of our problems, right? And now what's more popular than Angular today?
Everything.
I don't know, is that true? Is Vue more popular than Angular? I don't know. Anyways, the point is, if you separate the core functionality from the framework, you're going to save yourself a lot of trouble because change will happen and you'll adapt, but it's going to be a lot easier to adapt if you deal with that problem up front. So again, use what humans know, use what other humans are using, protect your humans. Let's talk about databases. So Santosh gave a really good talk about this, as I mentioned. Some advice you might hear floating out there is SQL is more transactional. Mongo is more flexible or easier to set up or whatever. Cassandra is more scalable. Like, these are definitely things that you'll hear floating out in the ether. And so how do you decide between a given technology? Am I missing a slide? Oh, I'm not missing a slide. Cool. So again, this is like the world's most boring advice, I know, but don't make it hard. Having one database in like the simplest case is going to save you a lot of headaches. Again, in the simple case, right? There's a lot of advice out there that's going to tell you like, well, use your graph database for this, and your columnar database for this, and your document database for that. And I think those are true, especially if you're starting from zero. But it does get a lot harder to debug when you have multiple sources of truth, right? If you really value things like transactionality, like it's kind of hard to guarantee that when you are storing things in different places, because humans, again, are bad at being consistent. So, I mean, my advice here is like avoid that multiple database thing as long as you possibly can until you can't, right? I know it's kind of boring advice because we all want to like play around with all these new technologies, but like the hard, at least again, my experience here, hard cold reality is it's more complicated. Take it or leave it. Store data the way your humans want to use it. So there is a place for these things. That's what Santosh's talk was all about. Storing, let's say, some complicated social network type structure or a folder structure in a relational database is hard. It's possible, but it's hard. It typically involves lots of denormalization or complicated recursive queries or whatever. Actually, let me pause here for a second. Who doesn't know what like most of these mean? Yeah, okay. Let's see if I can do a primer on this really quick. Okay, so relational databases, that's SQL, right, basically. We all know SQL, most of us at least heard of SQL. The cool thing about relational databases is they handle like dynamic queries like pretty well, right? You're basically storing it as like, here's a bunch of rows. And so the cool thing about that is they tend to discourage like storing the same piece of data in more than one place. So it's easy to keep it consistent in multiple places. And you can still query it pretty well by just writing SQL. So if you need the data to be consistent, right, and maybe other things like super high availability are not as big of a deal, then maybe you want to be skewed towards a relational database. Document database, for those of you who are not familiar, it's basically just kind of a blob of data, semi-structured. Oftentimes you can kind of query it. Oftentimes it's JSON. This is really great. It's often like one of the easiest ways to get started, right? Take my request from my client and just basically stick the thing right into my document DB. What could be simpler than that? The problem arises when, that tends to encourage storing things in multiple places because querying across documents and things like Mongo in comparison to SQL is typically slower, right? So if speed's more important than consistency, maybe you want to lean in this direction. This is the one that like nobody knows about. Who knows what column-oriented DBs are? Okay, that's what I figured. Santosh, of course. So basically, you take the SQL approach and you invert it. Rather than storing things by rows, you store them by columns. Again, kind of obvious. What that allows you to do is if you have like, let's say, all of the names of your users in one continuous block like on disk, right? So the aggregation, like numbers is probably a better example. If you want to compute an average or something, what's the weight of the car? Storing all of that in one big like sequence on disk is generally much faster than something like SQL can do it. So if your application is oriented around aggregations primarily, like maybe your logging framework or analytics of some kind, then maybe you want to look at a column-oriented database. However, you're shooting yourself in the foot if you need to ask questions about particular, pieces of data. That's the trade-off. And then lastly, graph databases. Again, pretty clear use case for this. If you have I would say recursive relationships, so one person could have 3 friends and those friends could have 3 friends and so on. That's generally hard, and in most databases, you're generally better off using a graph database for that kind of thing.
It's the real relational database.
It's the real, what does that mean?
Because it stores relations.
Yes.
It knows about relations.
Fair enough. Yeah. So, to review, again, I know this is boring advice. I know a lot of people are probably grimacing at this already, but I'm going to tell you, it is generally easier to keep it consistent. You'll have less inbound customer calls. Avoid it as long as you can before you stick it in multiple databases. And then understand the use cases for each of these, because inevitably you will probably need to store them in multiple databases. All right. This is probably going to be even stickier subject. Monoliths and microservices. So, advice you might hear. Microservices should be separated by bounded context, which is basically gibberish as far as I'm concerned. Microservices shouldn't share databases. You can understand this for sure. Microservices should be free to use their own languages and frameworks. So again, as I said at the beginning, all of these things are good advice in the right context. The first thing I would say about this is don't assume you're going to get more humans. A lot of the people writing blog posts about microservices are not your team. A lot of them are coming from these gigantic organizations, and they're giving you advice in the context, in the context of a very large team. I'm going to illustrate what I mean by this. So, Conway's Law. Who's familiar with Conway's Law? About half the room? Okay. Basically, it says your architecture is going to reflect your team structure, right? So if I have team A, B, and C, then guess what? My architecture is going to have 3 components. We tend to build things around the way that we're organized. And so what a lot of people, especially in the DevOps community, will tell you is you should implement the inverse Conway maneuver, which I really love. And it basically says, organize your team around the architecture you want, not the architecture that you have. Does that make sense? So restructure your team and the architecture will follow, which works. It totally works. That's a true statement. I think the danger is, again, this scale problem, right? A lot of people who are giving that advice are assuming that you have hundreds of developers, not tens of developers. And so what I would say is organize your architecture around the team you're likely to have. Because the reality is you probably are not going to be the next hockey stick company. And if you create thousands of microservices for tens of developers, you're probably shooting yourself in the foot. So, give yourself autonomy, give your humans autonomy, but not too much. So again, humans are bad at managing complexity. If you give them total freedom, you let them choose among a multiplicity of options, they're going to flounder a little bit, at least at first. And they have that need for autonomy and structure. Let's look at everyone's favorite team structure, the 2-pizza team. Who's familiar with this rule? Not everyone? Okay. Basically, this is, I think, Jeff Bezos. Am I right about that? Yeah. Jeff Bezos said, the ideal, unit is kind of this 2-pizza team. Basically, you can feed the whole team with 2 pizzas. And that's 7 plus or minus 2, according to his math. I disagree, but, These teams are fun, right? Who's been on a team like this? Most of you. This is the most fun, when you have this little autonomous unit and nothing else really matters outside of it. It's fun, it's easy to create alignment, it's easy to get 7 people on the same page, at least in relation to hundreds of people. Let's talk about this scenario. So, let's say you have 7 teams of 7 or so, right? So you got about 50 people trying to work together. I would argue that over time, there's a pretty high probability that like this person here is gonna maybe like jump over to this team at some point, or they're gonna need to collaborate or communicate or whatever. And my take on this, because this is the powered EMS scenario, we're about this size. My take on this is like, giving each of these teams total freedom to do whatever language they want is not a great idea, right? And you will see a lot of advice out there saying, just do whatever you want, man. Free love, like just choose your own framework, it's cool, man. I disagree. I think this is like, you can, again, we're social, right? We build off each other, we feed off of each other, we can help each other establish best practices. So in this kind of scenario, I would say you should probably enforce some kind of structure at this level. Let's talk about the next level up. So you probably can't even tell, but there's people, right? Way here. At this level, you're talking about like 300 people, so 7 times 7 times 7, something like that. At this level, you're never going to get all these people on the same page, right? This is, I think, when you're seeing those blogs, this is oftentimes who's writing them. It's pretty unlikely that this person here is going to talk to this person over here or move around to that team. So if you kind of think about it conceptually, what you're really saying is like, at this level, enforce some structure. At the next level up, give them the freedom, basically. That's what I'd say. So again, don't assume you're going to get more humans, and recognize that humans need a balance of autonomy and structure. So this is more of a request than advice. It's be good to your humans. Humans get burnt out, believe it or not. And humans are hard to replace. And then human happiness and productivity are very highly correlated. You know, if you don't take care of your people, if you're not good to them, then you're going to pay the consequences eventually. When they leave, when they're demotivated, whatever it is, just be good to each other. That's all I'm saying. So I'll leave you, I'm going to do a cliche thing here and leave you with a quote. It says, don't aim at success. The more you aim at it and make it a target, the more you are going to miss it. For success, like happiness, cannot be pursued, it must ensue. And it only does so as the unintended side effect of one's personal dedication to a cause greater than oneself. What I like about this is when you have these things like Agile and Lean, that like kind of, they tend to become hyper-focused on their own sort of internal measurements of success. It's kind of like, you know, if you focus on velocity, the first thing that's going to happen is you're going to slow down in velocity. Or at least, you're going to fake the metrics so that it looks like you're doing better in velocity, right? I think the better thing to do is to focus on the actual problem, right? The actual problem is us, basically. Sorry to say it, but it's true. We are the bottleneck to delivering value. We have this abundance of information and opinions out there in the world. We have a difficult time synthesizing it and applying it to actual problems that are right in front of us because the volume is so high, because people disagree, and that's fine. But what I will tell you is ignore the specific advice that I gave you. That's my take, right? What I'm telling you is just think it through for your team, for your organization. What will this really mean? What is the impact for my team going to be if we actually add Mongo on top of SQL Server, right? What's actually going to be the result of that if we have a 10-person team? Well, those 10 people are going to have to learn a whole new technology, basically. That's a big burden. That's going to be, there's a cost to that. Maybe it is the right technology, but, there's a balance there. Should you let them choose whatever technology they want? Maybe, maybe not. You're the only person who can tell me that. So that's what I would say. Remember, like, all of these systems, Agile, Lean, DevOps, they're all trying to solve the same problem, even if they don't realize it sometimes, even if they forget. The real problem here is humans. I know, the biggest bummer of a punchline for any talk, but it's true. Just focus on your humans, take care of your humans, help them be more productive, help them, not have to deal with drudgery and nonsense. That's fundamentally what you're trying to do in whenever you're trying to make improvements to your software development lifecycle. So, you can apply this to all kinds of things. Why do we do CI/CD? It's because it makes it easier for the humans who are working on the software. Why do we do Git? Same thing. Go down the list, that's why we do anything, really. So thank you. I know this is a controversial topic, but like I said, I get to run the meetup, so I get to choose the topics. So. All right. Questions? Or just angry comments? That works too. Who disagrees with me on something? That'll be fun. Okay, we have a disagreement.
So I'm just curious about the microservices remark that you made there. Comparing a company with 300 people and a small team with 10 or 20 people.
Yeah.
I'm just curious, what are your thoughts about microservices in that regard? What do you consider a microservice to be when you say that it's more dependent on the number of people in the company rather than a true definition of microservice?
Yeah, when I was being cheeky and saying bounded context is a nonsense term, that's kind of what I'm talking about. There is a logic behind the term bounded context, and I think specifically Facundo and Justin spoke not that long ago about bounded context. So but the thing is, it's kind of the wrong question in my opinion. It's again how many people are you likely to have? You can separate it again orchestrating a bunch of microservices is more complicated in a lot of ways than just having a monolith, right? So the more interesting question is basically what's the impact going to be? You can ask yourself what the definition of a microservice versus a nanoservice versus a monolith is. I think it's more practical to just go what is this going to mean for our team? That's the way I would answer that question. Does that make sense? Yeah. I can give you the textbook answer if you want. Yeah.
What's an example of relying too much on your framework versus separating business logic?
Yeah, a good indication would be is there a comment? No, okay. A good indication would be just if you, what'd you say?
It's not a comment, they're whole stories.
Oh, yeah. Yeah, so Angular is an example, right? So Angular has a whole bunch of, it's a very opinionated framework in comparison to something like React, which is a lot simpler. So you can kind of fully buy into it, right? You can say we're going to use Angular services and directives, and to some extent you should use all of those things. But when the day comes that it's no longer the new hotness and you can't hire for it, you kind of shot yourself in the foot. So the best thing that I think you can do is just use it, but the behavior of your application should probably just be a plain old JavaScript file, TypeScript file, whatever it is. Just separate that. On the backend side, it would be our API servers have a very thin dependency on actual .NET framework, ASP.NET, and everything beneath it is just basically plain old C#.NET. That makes sense. What else? He's just brewing. He's just angry over there. I can see it. All right, guys. I do very much appreciate your time. I hope this was valuable to you. And if not, then come tell me why, and we'll hash it out. All right. And we'll meet back here in 5 or 10 minutes for Santosh's talk. Thanks, everybody. Yeah? All right, let's do it. All right, everybody, we're going to get started with the second talk. Find your way back. I hope we don't disagree. That would be awkward if your slides disagree.
Or awesome. Would there be a rumble there?
We can duke it out. That's fine.
Right? It would definitely be.
All right, so.
It's definitely opinionated. That's
Oh boy. All right, so the second talk tonight is going to be about Azure API management. Who here has ever worked with an API gateway or anything like that? One, two, just a couple. Cool. This should be a good talk then. Take it away.
Round of applause.
Yeah.
Good evening. Thanks for coming. Thank you. So, obviously you have not had enough of the word microservices, so I'll toss some more of that. Anyway. So what I'm going to be talking about is, I like to talk philosophy. So, this is technology, but we'll talk about software systems and philosophies. So if you have any questions, any input, I'm completely wrong, I'm completely right, feel free to, especially if I'm right, feel free to stand up and applaud. So a little bit about me. I'm a Azure consultant at a local company called Nebia, and we were recently acquired by another company, so we are now New Signature. So I don't know which name to use, so I just put both in there. I'm also a Microsoft MVP for the Azure platform, which means I'm a community leader and share a lot of Azure-related information. I run the Orlando.NET user group, or OneTech, if you guys have heard of it, and I'm an organizer of the Orlando Code Camp. So Orlando Code Camp, the neat shirts, show up at Orlando Code Camp, or show up at a OneTech meetup. We have fun, so, or if not, we feed you pretty well at the very least. If you need to ever get in touch with me, you can email me at my, if you have money, then email me at my official email address, or if you want to get angry or agree with me, follow me on Twitter. So my agenda for today is pretty simple. I'm gonna try to make this as short or as long as you all want it. So what I'm going to be talking about is I'm going to start with monoliths. Then we will talk about hero for the day, microservices. And then I'm going to talk about something called API gateways as a general concept. And finally, I'm going to talk about Azure API management. And I'm doing it this way because I feel like I can, I work a lot in Microsoft Azure and I can dive straight into Azure API management, but I will honestly feel better if I explain it in a bigger concept as opposed to simply giving you a demo of the software. Microsoft people can do that. That's what they're for. They don't pay me, so I'm going to talk about whatever I like. And finally, maybe we can talk about other concepts, building a Death Star, I don't know. So we'll kind of build up. So monoliths, we talked about this. Who can tell me what a monolith is? We just talked about this. Come on, people. Yeah, go ahead. Gigantic blob of software that does everything. You had something, Kurt?
Just the single process basically running your whole system.
Okay, single process running the whole system. Yep, so all those answers are somewhat right, and maybe not. But it's basically, monolith is, it originated from the concept of building software from the past decade, I've been around long enough that when we were building monoliths, it was the in thing. So people used to love building monoliths. Nowadays, everyone is like vilifying it, but it had its time and place. So it came from the service-oriented architecture regime. So it's kind of based on this whole thing about most of the monoliths you see out in the world will probably follow this concept. They'll have a UI followed by a business logic, data access layer, and a database. That's what you'll see most of the monoliths do. But then it varies. It depends on what type of software it is. But the point is, it's a huge blob. The downside of monoliths is, let's say you had to make a small change to something in your business logic. Let's say you wanted to change, let's say you found a bug in your calculation for the tax for a product and you wanted to fix it. You'd have to do a wholesale update of the system, which means you'd have to bring the whole website down, take it offline, apply the fixes, spin it back up. And these days you cannot afford to have that type of downtime. So it was basically less agile, not very conducive to modern day DevOps or CI/CD type processes. So then we went towards this thing called microservices, which we have talked about a whole bunch of times. I will not try to go for the textbook definition. I don't even remember what it is. I just know that microservices are there. So, and I don't want to cover it because this group has had enough microservices, from Alex to Justin and Facundo talking about it. So I'll just skim it. Basically, what you do is you take a monolith and you break it down into pieces. You take the core functionality and try to break it down into different pieces. The advantage of this is each different microservice can be built and deployed independently. So let's say you had a tax calculation microservice in there, you could simply update that one instead of taking down the whole system and updating it. So it's really conducive to CI/CD and DevOps type approaches. So when you have now you have a bunch of microservices. So what next, right? So you have microservices. By the way, before I proceed with this talk, I just want to get a good feel of on the audience. So how many of you here have worked with microservices? All right, so a good bit of you. How many of you have worked with, yeah, no, I noticed that you didn't lift your hand. So how many of you here have done any kind of work with the API? All right, so that's a good bit. So an API is basically application programming interface, I guess. And it is what feeds data from a database, like it transmits data from a database over the wire. I guess that's, I don't know the textbook definition, but that's what it does. So an API these days is usually in a JSON format. So if you ever do any kind of coding, whether it be with C# or JavaScript, what you're doing is you're contacting a URL, whether it be on the internet or your local network. You're contacting that URL over HTTP, HTTPS, and then you're saying that I'm making this call, and I'm either trying to send some data, I'm trying to receive some data. So a send is basically a get. When you pull data, that's basically a get. A send can be a put or other things. So that's what an API is, and it's based on HTTP principles, and most of those are REST-based JSON services. So just a quick primer and that. So let's say these microservices are basically have different APIs, and these APIs are talking to client applications. So this is a common scenario these days. So you have a product. Your product has a web page. A product has mobile apps. It could be an Android app. It could be an iOS app. It could even be an IoT app. So you have a whole bunch of different clients that access your APIs. So let's say your clients talk to the APIs directly. What happens at that point? Number one, each of these clients, let's say you take a mobile app, it would have to make individual connections to each of that microservice, right? You take your web app, it has to do the same. So that's two type of clients. They made 6 different connections. Now, this is a very contrived example. In most real-world examples, you have dozens, if not hundreds, of APIs. So do you want your clients making all these connections? And not only that, let's say you have your mobile app talking to microservice 1, and you have your web app talking to microservice 1 directly. What happens when microservice 1 has a change? Let's say microservice 1 returns data on inventory, right? And suddenly you decided to add an attribute to that inventory, or even worse, you decided to remove an attribute from that. And so you'd have to go into your client app and update that. And you'd have to go into a mobile app, publish an update for that. You have to go into your web app and publish an update saying that this was updated. So you have to update a bunch of them at the same time, which makes it really hard to keep up. So when a signature changes, that's a huge issue. What about security? So let's say you have your microservice 1, 2, and 3, and you have all these different type of clients talking to it. You'd have to, the communication obviously has to be secure. So what you're forced to do is, you're forced to implement a point-to-point security between each of these microservices. So that's a huge overhead for your development team. And the other issue that we have come across, I work with Troy over there. Troy, say hi to everyone. We do a lot of consulting work. One of the number one scenarios we come across that's a huge pain in the what is you have microservice 1 that's out in the cloud, and you have microservice 2 on premises. So how do you handle this? Like, how do you even talk to something that's on premise directly from one of those web or mobile applications? So the communication becomes a huge issue. And finally, performance and networking. So let's say microservice 1 is selling TVs, and microservice 2 is selling computers. And for Black Friday, someone put a sale out on computers. So microservice 2 is getting hammered. So what do you do at that point? Like, you don't even know where the traffic is coming from and how to handle all of that stuff. So what API gateways do is, API gateway is basically a layer of abstraction that sits between your microservices and your client applications. So the number one thing it does is, let's say you have your client application, which is a web app, mobile app, and so on. If they want to talk to microservice 1, they talk to the API gateway. So it kind of acts like a router. So that's point number one. So you don't have each one making individual connections directly to the microservice. So the advantage of this approach is, let's say you made a change to microservice 1. All you have to do is, you have to tell the API gateway that I made this change and you handle it. So you can handle it in one place, and all of the client applications would be okay with it. So you can even make your change completely transparent to the client applications. You are not stuck maintaining or trying to push changes to multiple client applications at the same time, so your apps don't stop working. The other thing is security. So one of the things that I mentioned in the previous slide was a problem was because you have different clients talking directly to microservices, you have to handle the security bit end to end between those connections. In this one, what you can do is, I don't care if microservice 1 is completely open and microservice 2 has authentication. All of that is handled on the right-hand side of the API gateway. And the API gateway basically handles any communication that comes in and goes out. So I can say that I'm going to leave microservice 1 open. I don't really care. What I'm going to do is, any client device that talks to me, I'm going to check it for whatever security credentials there are. So the other advantage we derive from this is you can standardize your security across the board. Any questions so far?
I have one question.
Yeah.
So if Microservice 1 removes a field from one of the APIs, how is the gateway called?
If microservice 1 reboots, is this
If it removes a field, like the case we talked about earlier, because if it changes the contract and removes some data,
okay?
right? So how does the gateway called?
I will get to that in a second. Yeah. So good question. So the question is, what happens when you remove a field from one of the microservices? How do you handle? So I'll get to that in a second. So the other things API Gateway do is they allow for mocking. So let's say your team is starting to build out a new feature. I can set up an API Gateway endpoint that talks to clients that provides completely fake data, but it's in the same format as the final data is going to be. And when my team finishes building the microservices, I'm going to plug it directly into that endpoint. And that way it's completely transparent to the client application on how I brought a new microservice online. Whether it doesn't matter if I have a microservice or not in the backend, my API gateway is mocking that result. Yeah.
Why do you have container and core web host on the API gateway? Is that something? Is that because it's something that we do, or that you're talking about the Azure product offering, right?
Are you talking about this one?
Yes, this container and web host. So if I see that, I'm thinking it's something that we do. But I thought you were talking about.
This is API gateway as a general concept, so
okay.
it could be on a container, it may not. But most of those run on containers anyway, so I think that's, but it doesn't have to be on a container, it could be on a server.
But you're not talking about the Azure product offering, you're talking about the concept in general.
I'm talking about the concept in general. So my next slide is Azure API. The other things API gateways do is they provide analytics. And they also, because they provide analytics, let's say you're getting hammered by a particular client or for a particular microservice, it will provide you that analytics which will help you scale up that microservice. And you can automate that with CI/CD processes. So, which brings me to my main talk of today, which is Azure API Management. Azure API Management is basically it's Azure's version of an API gateway as a service. So what that means is it's completely hosted by Azure, and you can tweak it programmatically or using a GUI to make it work the way you want to. So it's hosted on Microsoft's Azure Cloud. Did I miss a slide? No. Oh. Sorry, my slides got a little bit out of order, but I wanted to talk about this one. Why am I talking about Azure? I want to make sure I provide this context before I do that. API gateways, you don't have to just go with Azure, even though that's what I would prefer, but there's a whole bunch of different API gateway products that you can use, and these are some of the options. And I'll kind of try to go through the differences between them. So you have Azure API Management, which is, you can replicate it across multiple nodes, and it's a platform as a service offering. Azure API Management is proprietary to Azure. It's not open source. You cannot deploy it on other platforms. The advantage of Azure API Management, and the couple of bigger ones I've seen, is it has inbuilt caching. So let's say you're making the same request over and over, it'll automatically cache the results, so you get improved performance. So that's one of the big advantages that seen with Azure API Management. And I'll dive into that in a few minutes. And another big advantage is because it's Azure, and they're really good at networking, you can connect an on-premises microservice to the API gateway using a VPN, and it all happens in the background. It's really secure. So that's one of the huge advantages that you derive from using a mature cloud provider like Azure. There's APG or APIG, which is basically API gateway. They are, again, a proprietary company. It's a slightly different model in that you have to configure nodes with different roles. So they have, like, you have the publisher, subscriber role type things. So you have to configure those nodes. So that's a huge pain when you do it. It does need a separate data store for caching. So if someone asks you why you're using Azure or APG, you can tell them that I like the inbuilt caching mechanism, right? So the advantage of APG is you can deploy it on premises. So if you want to do everything on premises, you should probably go with APG. AWS Gateway, that is API Gateway, that's very similar to Azure. In fact, you'll see that it is identical right now. There will be minor differences. I don't know enough about the AWS part, so as far as I could tell, they're pretty similar. There's another one called Express Gateway. That's an open source one. And you can deploy that on premises. Or you could even fork it if you feel like writing your own code. But again, the disadvantage of that is you need a separate data store for caching. So you have to configure Redis or some other data store for caching to work on that. Okay. My slides got out of order, so having shown that slide, now I want to jump into API Gateway, which is Azure's API Gateway as a service. It provides two things. It provides the API Gateway, which is basically the service it accepts API calls and routes it to the proper microservice. It provides this whole security, and you can do different types of security, like you can do token-based authentication, you can do JWTs, you can do Azure Active Directory, so there's a whole bunch of security, so it's really good at security. You can set quotas and limits, so I can say that I'm giving you, developer 1, a key. I'm giving you, developer 2, a key. And developer 1, I'm saying that if they come more than 10 times, you come and hit the website or the API more than 10 times in a minute, I'll rate limit you. So you can handle that really well with Azure API management. And key manage along the same lines, I can hand out keys for different levels of subscriptions. So it makes management of that real easy. Transform APIs, so I can take like a simple REST-based API, which time permitting, I'll do a demo to show you that. I can take a simple REST-based API and deliver it to API gateway, but I can also take things like a Swagger endpoint and deliver it through the API gateway or API management gateway. Or I can take a SOAP service and I can either deliver it through the API gateway as a SOAP service, or I can convert it to JSON through the API gateway, which is, if you work in .NET based systems, one of the things you'll come across is old SOAP services that are out in the wild, they're lurking, just ready to trip you up. So you can use this to convert that to JSON and just hand it over to your developers. And it provides really good analytics. You can integrate with Azure Application Insights. You can do Azure Monitor and other services, hook it up with other services. The other thing it does is it provides a developer portal. So once you build an API, you want developers to build off of it. So it provides a developer portal where it provides a lot of automatic documentation. It allows you to manage keys, gives you analytics, and gives you different tools to test the APIs. So this is, the first point is the one that I was talking about, is what happens when you remove a field? Is your app going to crash? So yes, you can, if you remove a field, your app will crash, but there's a couple ways of doing this. You can do something called revisions, and you can do something called versioning. The difference is, let's say that I add a field, and that's not going to crash my app. Non-breaking change is a revision. Let's say I add remove a field, or I change the data type, and it's going to crash my app. That's a breaking change, and that's a version. So it allows you to handle both, which is really cool. So if I have a breaking change, I'll create a new version, and I'll slowly transition my clients off with that. So that's how I would handle it.
So both versions will be alive.
Both versions will be, you can handle as many versions as you like. Yeah. By the way, API gateway, when you create it, it charges for the whole thing. It doesn't matter if you put 10 APIs or 1500 APIs underneath it, you get charged the same amount. So you can manipulate it whichever way works best for you.
Is it by number of calls? Number of hits?
Yeah. Yeah, it's service level, yeah.
So it's not quantity of APIs, it's how often it gets used.
Yes, correct. And features, like if you want to connect to via VPN to your on-premise, you have to go with the premium one. So just a couple of things. And we talked about some of these other things, which is logging, caching, API keys. So
is the versioning done by like different URLs, or is it done by different headers, or how does it do that routing for the versioning?
yeah, so that is up to you. You have a lot of flexibility on how you configure the URLs. So you can say that I have I have an API with version 1 and version 2, and I could append V1, V2 at the end. I could start with V1, V2 after the host name. So we have a lot of
So it's
flexibility.
up to you, it doesn't have a prescribed way of doing it.
No, it doesn't have a it doesn't prescribe things, so it gives you a lot of flexibility. Okay, so what I'm going to do is I will quickly jump into something I created. So I'm going to run it in a duplicate screen mode. Are you able to see my screen now? You see that one, okay. I'm showing you screen 2. Okay, let me see. I'll quickly do this. I will end the screen share. And I'll start the screen share. And I'll do the entire screen.
I see that's one.
You see this one?
And separate.
It's probably lagging, right?
Yes.
Okay, awesome.
Sorry.
Are we able to see this, or is it too small? How about the back? Are you able to see the screen?
Try to make it bigger.
All right, fine. That's good? Okay. Well, I was not going to make it any bigger anyway. All right, so I have 3 examples in here of services that I'm going to provide for this. So microservices, in this very contrived example that I'm about to do, a microservice is something that takes a API and passes it on somehow. So the first one is very simple. It's a REST API. So it's a very simple REST API, the most basic REST API you can ever find. And I'm going to add this and pass it through my API gateway. So the way I do it is I can add an API gateway. This is an Azure portal. And I'm not going to try to add an API gateway right now because it takes a few minutes to provision, and I really don't want to do that. I hate waiting for things, but you can simply click in here and when you say create. Now this is how I would do it the first time when you do it, but the more recommended methodology in Azure is using ARM templates, and the reason you want to use ARM templates, Azure Resource Manager templates, ARM, like ARM. You want to use ARM templates is because they're infrastructure as code, and you can take once you create one, you can pass it on, like check it into source control, make changes, and deploy it with pipelines using CI/CD. So that's what you want to do. So to create an API management service, you have to give it a name, a location, and Azure has different locations. So you could do it in US, or different locations in US or anywhere in the world, for that matter. And we provided an organization name. Now this is the most important part, the pricing. When you start off, use the developer level, and then once you go into production, you want to pick between basic, standard, and premium. And the reason people pick premium is because you know that basic and standard don't have virtual network connections. So if you ever in the future will connect to on-premises service, then always make sure that you use premium. But you can start with a basic or standard and then change it using the portal to a premium. So that you're not stuck with your final choice. But you'll also see the cost. It's not for the faint of heart. But again, you're not paying it, your company is, so don't worry about it. So pick wisely. The other thing is enable application insights. This will actually give you Azure Application Insights is an entire talk or subject by itself. It provides a lot of metrics into how your application is doing. So having said that, I already created one because once you start creating a API, it takes at least half an hour to provision a gateway. It's a gateway. Actually goes out and provisions the machines and the virtual network gateway and everything. So it takes a long time. So I'm going to add an API to this, and I'm going to show you how to use it. So the first one is I'm going to add a REST service. So I have a REST service on here. So I'll just add the simple one, which says dummy REST API employees. So we'll add that on here and see how to use it, right? So it's very simple because it's a REST API and a fairly straightforward REST API. I'm going to give it a name. We'll call it employees. And the web service URL is this one. So this is where I can play with the names. So I can say that this is I can either give it just the base name and do inside the API I can provision the rest of the names, but I can also give it a suffix. So when I call it, I'm going to call it employees. So what this tells me is instead of typing in this whole API/v1/employees, I'm just going to use the shortcut for that. So it offers a lot of flexibility in how to do it. And products, I'll talk about this in a minute, but I'll just select unlimited for right now. So I'm going to go ahead and create this. So it did that already. So I don't have anything in here, but what I want to do is because I gave it this particular API, the GET request, so what I'm going to do is I'll provision that, I'll add an operation and say that my operation is going to get all employees. And because I already provisioned it, I'm simply going to add a / at the end and save it. And this is it. So now I can go in and test this API, begin testing it. And what this API does is, when it finishes running, there must be a lot of employees in there. So it made this particular call, but this call was actually a translation of this call, right? So my test was basically, it said, it gave my API host name, and then it made the call for employees, and it converted that to the API/v1/employees and made this call. And you'll see that it sent a key and something, and then it returned some values. So instead of doing it from here, I'm going to actually use something called Postman. Who here has used Postman? Okay, cool. So Postman is like a simple REST client that you can do get and put type request. So in Postman, what I'm saying is that for employees, I'm making this call and I'm feeding in the key, and the key is premium. So let's talk about products. So one of the things you can do with your API manager is you can productize your API. So you can say that I want to provide different levels of service based on, let's say I have a client A who's paying for the basic service and client B who's paying for the premium service. I want to provide access to an API or not, or provide different levels of service. And the way you can do this is API Manager has this concept of products, and by default you get starter and unlimited. These really don't mean anything. You can delete these and assign your own product names. But what these do is they provide subscriptions. They provide these subscription keys, and you can use these keys in your API calls, and that is how it discriminates between client A versus client B. And so in this case, I am in, which product am I in? Starter products. So I'll go back and so what I'm doing is I'm taking the API keys from here and I'm simply giving it to my clients. So this is the API for starter product. Similarly, if I go to the unlimited product, it will give me a different key. And in my Postman application, what I did was I basically programmed the two keys in as basic and premium. So that makes it programmatically easy for me to hit the API. So now I'm going to hit it with a premium product key, and this is sending a request, and you can see that it gave a response that has a bunch of data, right? So earlier when I created the API, I only assigned it the unlimited or the premium product. So what happens when I give it the key for basic? What do you think will happen? Sorry? Less data?
Whatever you told it to do.
Okay, I did not assign it the basic product at all. So what do you think will happen? Right? So one of the 400 errors, right? So in this case, it automatically translated it and it gave me a 401 error, and it says access denied due to invalid subscription key. So that is one way I can put an API out there and I can control it. So for instance, like you may want your mobile app to have access to a certain product, but not your web app, or vice versa. A lot of companies do different types of tricks. If I'm logged in as a premium user, I want to have access to certain sections of the product, and this is one way of controlling it. The other cool thing you can do is, how am I doing on time? Okay. And I'm almost done. I'll quickly go through a few features and I'm done. So if it ever decides to load today, so I want to show another cool thing I can do. So let's say I go to this application. I can do something called, so you have a whole bunch of policies you can apply to this, your API manager. So you can do rate limiting, you can restrict by IP address, you can transform your responses from JSON to XML, XML to JSON, and so on. So in this case, what I'm going to do is I'm going to say that limit rate per subscription. And then I'm going to say that I'm going to rate limit, and I'm going to say that if you make more than 3 calls and let's see, 3 calls and 15 seconds, it's gonna do something. It's gonna do something horrible. So, and I don't know what that is. We'll see in a minute. So this is my rate limiting. So 3 calls in 15 seconds. So I'll go back and I'm gonna change this to a premium so that it's something that actually returns data. So 1, 2, 3, and the 4th one should fail. And sure enough, it failed, and it gave a 429, which is a standard for rate limit exceeded. That's like the standard HTTP response for that. So you can say that I'm giving my developer, I'm rate limiting my developer, so my developer does not hammer my application, but I'm giving unlimited access to my client, or vice versa. So you could, you have a lot of flexibility in handling it. So some other cool things you can do with the API manager is you can actually configure identity providers. So you can say that I can use a username and password identity provider. I can do some kind of OAuth 2 type identity provider and so on. So let's say you have clients that are logged in via web applications that are using OAuth 2 or something. You could have them directly connect to your API manager, and because this has the connection configured, they wouldn't have to go through the authentication screen because they already have the tokens. You can add external cache, so each level of API management comes with its own preset amount of cache, so that's a few megabytes to a few gigabytes, but let's say you have massive operations like hundreds of gigabytes, you can configure an external Redis cache from here. We talked about the different levels of scaling over here. The other thing I wanted to talk about was the fact that you can actually have your API manager, if you select the premium version, you can run it in more than one locations, and it'll handle that transparently. So I can say that I want my API manager to run in Central US, and I want my API manager to run in East and West. So it'll automatically, whenever a request comes in from Eastern US, it'll redirect to the East instance, and Central, it'll redirect to the Central instance. And it's handled transparent to you. The other cool thing is I can configure the throughput. So 1 unit gives you a certain amount of performance. So let's say I have a lot of customers on the East Coast and West Coast. I don't have a lot of customers on the Central Coast. So, not coast, on the central of the country, center of the country. So actually there are coasts, but there are lakes. So I'm being pedantic. So I can say that I want to configure higher performance, more units in different regions. So I can have 2 regions on West US, 3 on East, and 1 in Central. So I can configure different levels of performance based on which location is being used. So, but this is only available at the premium level, and it's priced by unit. So if you configure multiple units, you get charged more. So just keep that in mind. Virtual networks, let's say you have, this is the most common scenario we come across as consultants. Someone has something that's on-premises because they don't freaking want to move from on-premise to the cloud for whatever reason. So what we do is we configure virtual networks, and we put the API management service in a virtual network on the cloud, and we connect that virtual network to the on-premises network using a VPN gateway, and that way you can talk through a secure back channel. And of course you can do application insights and metrics and alerts. I think that's all I have. I'll also end with a cool slide like Alex did. So you can basically, that's famous dude, talks about dividing and conquering. So with microservices, you can do that. Take a monolith. It's hard to deploy, hard to make changes to, hard to manage. Divide and conquer. So, and hopefully API management helps you in your journey. There are different types of API gateways, like we saw, APG, AWS, Azure. So we can choose whichever one works best for you, but do make sure that you're following some of the best principles and look for what fits you best instead of saying that I am an Azure guy or I'm an AWS guy and come hell or high water, this is what I'm going to use. Don't do that. Just be more pragmatic. That's all I have. If you have any questions, feel free to hit me up at any of these links, and I will be more than happy to talk to you or argue with you about various things. So thank you very much. And I'll take any questions after.
One very fundamental question.
Yeah.
It's the kind of question that I feel embarrassed to ask, but I feel like maybe three other people would not ask the same thing. So you've got this gateway between your API and your client, and you have different authorization levels. So I imagine that you've already got a key that the client already has. This is one of the headers in order to be a premium user when it makes the get call. Is that right? So
Yeah.
that's like a pre-step to this whole thing to be able to be a premium user. The client already has that information.
Right.
Okay. So that probably answers the rest of my question, which is the whole request that goes in, does it get to your endpoint in the same form that it got to the gateway? It's like all the headers and everything you pass in. Are there any extra embellishments the gateway uses, filters out, or adds again on the way back out? Or does your API see everything that the gateway sees? Is there a mismatch between them? Is the gateway ever remove things?
Right. So that's a good question. So the question is, and I'm repeating it so I understand it correctly. You get a whole, you're sending a request with the API key and stuff, and the question is what happens after it gets to the API gateway? Does it get transformed before it goes to the microservice in the backend? And similarly, when it comes from the microservice to the backend, what happens? So currently, the way I did my example, what I did was, and that's by default, it transformed the URL and it took the key and it authenticated the key against the gateway, and then it let the rest of it pass through. Now, if I had a post request, right, with the body, I could have just let it pass through because I authenticated with the API key. So I could simply let it pass through to the backend as is.
So the API key would be filtered out and header before it went to your actual backend service?
Right. So right now it is. Right now it is filtered out as default action. But you have the option of letting it pass through. So there is a pass-through option. Remember the policies I showed you which had the rate limiting and stuff?
Sure.
So with that you can say that, okay, I have this API key came all the way, but I want to let it pass through to the end, to the microservice at the end. A common scenario for that is JWTs. So people, when they log in with the applications and it generates JWTs, you send it to the API gateway and it just passes through to the microservice because it can further trigger different things on the microservice end before sending the data. So yes, you can let it pass through, but that's not the default option.
So the idea is that these cross-cutting concerns that the gateway handles, it fully handles, and your API can say, we printed them.
Yeah.
That way they can change,
Right,
And your
right.
API won't have the information to act on, so you're not going to break anything.
Correct, exactly. Yep. Yes.
To follow up on that, does it do any request response correlation where like it might enrich something on the way back out in the response?
So on the way back, you can transform the response. So you can do different things like you can take the response, you can, let's say it's a JSON response, you can transform it by adding or removing fields, or you can transform from JSON to XML, XML to JSON, you could add headers on the way out, so you can do different types of thing. Yeah.
What about user identity? How would that normally be represented? Because your API is going to have to know the identity of the user that's making the call. In all cases,
Right. So the,
well, someone.
so the backend API, right?
Yeah.
The backend API. So that's why I was mentioning the JWT case. That's a very good example is you send a JWT and you just let it pass through. And
What is JWT?
It's just not token. It's so it's a token. You encrypt a token. It's basically base 64, and then you decrypt it with JSON, and it'll have things like your user ID, your email, etc. And then it will make permissions. So at the gateway level, like that's your yes allowed in. And beyond that, your app might want to decode that and pull more data out of it than the gateway even cares about.
Actually, there's all actually still be able to
Last one. Last minute.
Yeah, sorry.
No, it's it was
Cool, I'll check those for one.
Yeah.
I'll probably go to the meetup and the app as well.
Yeah, so if you go on the last meetup, you should find a link that we can post to.
Thank you.
Sorry. That was your question.
no, that's okay. Thank you. You probably explained it better than me, so I don't mind. I'm really bad at textbook explanations. So good. Anything else? Questions? What do you think about the product? Like it, not like it, suspicious, or want to try it out? Yeah.
Would it be practical for small applications
Uh,
to use Azure?
It seems kind of pricey, but what about for small applications?
So there's a basic level. So yeah, you can, if you have a small application, just use the basic level. I mean, it's not going to be free. I mean, free is as good as it gets. So there's a developer level that you can use for developing, and there's if you go to the scaling and pricing, you can see the pricing for various things, and you just have to decide what works best for you. There's the basic, standard, premium. You don't have VNet support at these levels, and different performance at different levels. So you just have to figure out what is your best option. So 150 a month for an API gateway that handles multiple microservices in the background. To me, if I'm running a technology group, that's a no-brainer. So that's just up to you on what your usage is or how much traffic you're handling. You just have to figure it out based on that. So yeah. So to answer your question, if you have multiple APIs or you want to standardize your APIs and how you access them, this is a very good way of doing it. So, any other questions? One of the things I forgot to show in this demo was the developer tool. So I know that I'm kind of going back into this, but when you add APIs, you actually have this developer portal where you can go in and manage the tokens and other things, and you can also get explanations of what the APIs look like. So you can provide this to your developers. And a couple of other things is that this is really good at is, let's say you have a Swagger-based endpoint or Wisdom, which is a SOAP service. You can actually, so this is a Swagger-based endpoint that I got from the web, and if you add it in here, and let's say it's a pet store, right? So I'm going to call it Swagger Pet Store. So it automatically went out, and it actually got the display name of the API, and not just that, you can assign it various products. When you derive from an endpoint that has any kind of discovery language, it actually goes out and finds all the operations and adds it. And when you go to the developer portal, the other thing you see is because it's Swagger, you get all the documentation of all the calls with the details. And because this was in Swagger, it simply imported it. So this is the power of APIs. So, always when you create APIs, use Swagger or some kind of discovery language, and you can do that with API gateways. So that's another cool thing you can do. I almost missed out on that one, but thanks to the discussions we had, I was able to go back. So if there are no more questions, thank you very much. Thank you for coming to my talk.
Well, again, thank you all for coming out tonight. I'll add two things at the end here. One is, if you don't mind sticking around helping me set back up the room, that would be super helpful. And two, if you are now inspired to give your own thoroughly opinionated talk and make people angry, then you can come talk to me or reach out and I would be happy to get you scheduled.
If you're hiring, can you make an announcement?
Yes.
Can I
Wait.
make an announcement?
For me? Yeah, for you. Okay, go
If
for
you
it.
have a job here, you're going to do fun things. Hello, I work for a company called LMS. It's a marketing company that has a tech side. We're looking for a level 1 engineer and some backend stuff. But if you are looking for a job, or you know someone that's looking for a job, I'd love to chat with you. Also, like showing you the job description because I don't know the job.
Any other hiring or people looking for a job? Any connections we can make? Missed connections, etc. No? All right. Well, again, if you can help me set up the room, that'd be super awesome. Otherwise, I will see you in a bit. Cheers, guys.